Hello everyone, welcome back. In today's video, we're going to see how the JavaScript engine executes asynchronous code, right? In the previous video, I explained how the JavaScript engine executes synchronous code. So you can check that out. I'll leave a link in the description. Now, JavaScript is a synchronous single-threaded language that runs in the browser, right? So the JavaScript engine is in the browser, but the browser has other features apart from the JavaScript engine. It has the local storage, it has the HTML DOM, it has the console, it has the timer, and the rest of them. Now, these browser features are available to us as web APIs. We can use them in our JavaScript program. They are available to us in our JavaScript program as web APIs. So when writing JavaScript, we use these web APIs to interact or communicate with these browser features to be able to execute asynchronous code, right? Because JavaScript is single-threaded, it can only do one thing at a time. So these web APIs help execute asynchronous code without blocking the thread of execution. Some of these web APIs are the set timeout, that triggers the timer in the browser, the console API that we use to log messages to the console. Yeah, that's part of the browser. It's not part of JavaScript. The local storage, and the rest of them. So we're going to use this simple JavaScript program. We're going to use it to understand how the JavaScript engine communicates with the browser APIs to execute our asynchronous code. We're going to be using this program here. So when this program runs, the first thing that happens is a global execution context gets created and added to the call stack. The global execution context is where all our top level code gets executed, right? So in the video I made on how the JavaScript engine executes synchronous code, I explained the execution context. I explained how an execution context is created and what happens inside an execution context, right? And the call stack as well. So we're not going to be going into details of that. We're not going to be talking about how memory gets allocated in this video. So you can check that out. But now we have our global execution context and it's been added to the call stack. Now, the first thing on our program here is this setTimeout function, this function right here. So we're calling the setTimeout function. A brand new execution context will get created for the setTimeout function and added to the top of the call stack, right? Now, the setTimeout function is a web API provided by the browser. So setTimeout here will trigger a call. It will trigger a call to the timer in the browser. Now it's going to start the timer with the time we specified here, which is 6,000 milliseconds, right? Now this callback function that was passed to set timeout is going to get registered in the web API environments. The web API environment here is in the browser. This is our web API environment. So this callback function that was passed to set timeout is going to sit here in this web API and wait for the timer to expire, before it gets executed or before it gets ready to move to the next stage. Now, the thread of execution is ready to move to the next line on our program. So on the next line, as we can see, we have a console.log statement, right? And it's a function. The console is a web API that is available for us in our JavaScript program, but it's a function, so it'll get pushed to the call stack. When it's added to the call stack, an execution context will get created for it, and then whatever is inside will start its execution. Now, what's inside is I have started cooking, a string I have started cooking. So it will log I have started cooking to the console. This our console here is part of the browser environment. So it will log I have started cooking to the console, and then it's done. Its execution context will get popped off the call stack, and then we'll move to the next line, or the thread of execution moves to the next line, but we're the thread of execution. Okay, on the next line, we have, on the next line here, we have a fetch function. Yeah, we're making a fetch request. Well, fetch is one of the web APIs provided by the browser. Okay, now fetch is going to get pushed. Let me push it to the call stack. It gets pushed to the call stack. A brand new execution context gets created for it, and it immediately returns a promise object. Now we're not going to be looking at what's inside this promise object in this video, maybe in the next one. But this callback function here, this callback function will be executed once the promise is resolved. That is when the data is back from making that network request, right? Fetch here gets popped off the call stack and is executed in the browser. Because it's a web API, it needs to go and make that request, right? It needs to go and get the data. Now, this callback function, the fetch callback, is also registered in the web API environment, where it's going to be waiting for the data to be returned back. It's going to sit in that web API environment, waiting to be executed or waiting to be moved to the next stage. We'll find out. So the fetch function is sitting here with our cook callback. So the fetch function is sitting here with our cook callback function, right? Now let's say the network request has been completed. We have our data back. We've received our data. Now we got our data. Let's say we got the data back before the timer expired, before the timer finished its countdown. The timer is still counting, right? The data came back really quick. Now once this data is back, the this fetch callback function will now move. It will move from the web API. It will move from this web API environment into the microtask queue. I know I haven't talked about the microtask queue or the callback queue, but this is very key. This is very important, so please pay attention. The fetch callback has now moved from the web. We didn't move it. The fetch callback has moved from the web API environment now to this, our microtask queue, right? Now let's say our timer is up as well. The timer has expired. It has finished its countdown. Now cook callback is ready. The cook callback function is ready to be moved as well. Guess where it gets moved to? It gets moved to the callback queue. Now I know what you're thinking. What's going on here? Why are they added to different environments? They were both chilling in the web API environment. Why are they being separated? Well, let me explain. Now, normally, callback functions like this wait to be executed inside either the microtask queue or the callback queue, right? So these queues are used to handle asynchronous code. Because, for example, if our timer here is up, the callback passed to the set timeout function cannot just move straight from the web API environment to the call stack, right? It doesn't make sense. It has to wait somewhere. So callback functions will be moved from these queues one after the other to the call stack when the call stack is empty. Callback functions will only leave either of these queues when the call stack is empty. So we have these two queues, the microtask queue and the callback queue. But the microtask queue here has a high priority, right? So whatever callback function is here, callback functions that are inside the microtask queue will be executed before callback will be executed first. They will be executed before callbacks that are added to the callback queue. It's callback, a lot of words. So I need to say that again. We have these two queues, right? The microtask queue has a high priority. So callback functions in the microtask queue will be executed first. They will be executed before callbacks that are in the callback queue, right? And now callbacks that are associated with promises are passed to the microtask queue. Let me say that again. Now callbacks that are associated with promises are passed to the microtask queue. That's where they wait to get executed. So if we have 10 callback functions or 50, I don't know how possible that is, but if we have 10 callback functions, for example, in the microtask queue and one callback function in the callback queue, the 10 callback functions in the microtask queue will all get executed. They will all get moved to the call stack one after the other before, the 10 of them would go before the one in the callback queue will move to the call stack. That's just how it works. So now let's talk about the event loop, right? The event loop has just been sitting here. Now what it does is it keeps checking if there's anything on the microtask queue, if there's anything on the callback queue that needs to be added to the call stack, right? It's like a middleman. So it only adds callbacks from either of these queues if the call stack is empty. It needs the call stack to be empty, right? That means all the normal code in our program has to run first before any of these callback functions leave the queue, right? So it only adds callback functions from either of these queues. I mean, starting with, you know, the one that has priority if the call stack is empty, or when the call stack is empty. So if we had, for example, if we had like in our little program here, if we had 10 other functions or 50 console.log statements, they will all be executed before any of these callback functions leave the queue, right? So if it finds the call stack empty, it'll start pushing callback functions from the microtask queue to the call stack one after the other, you know. And then when it's done executing whatever is when it's done moving whatever is in the microtask queue, it'll start moving callback functions from the callback queue in the same fashion, one after the other. So now we understand why this fetch function was added to the microtask queue, right? And the callback function that was passed into set timeout was added to the callback queue, right? Meanwhile, there's nothing left to be executed in our program again. I mean, there's no global code left to run, and the thread of execution is done. The call stack is empty. So here comes the event loop. So the event loop checks, right? So the event loop checks, is the call stack empty? Yes, the call stack is empty. And then it checks, is the microtask queue empty? Does it have any callback function? Yes, it does. So it pushes the callback, it pushes this callback function to the microtask queue for its execution. Now, the first thing that happens, as usual, an execution context gets created and then its execution begins. It has a console.log statement. So console.log statement is a function as well that gets added to the top of the call stack, and an execution context is created for it as well. It prints my pets are here to the console. This is our console here, and that's it. The console.log statement is done, so it gets popped off the call stack. And now the function here, the callback function here, has also completed its job, so it gets removed. It gets popped off the call stack as well. Now the call stack is empty again, and here comes the event loop. It goes to check, does the microtask queue have anything, any callback function? It doesn't, it's empty. And then it checks, does the callback queue have any callback function? Callback queue have any callback? Oh God. Does the callback queue have any function to be executed? Yes, it does. Now, as usual, the callback function for the set timeout gets added to the call stack as well. And then it's ready for execution. An execution context gets created for it as well. And it also has a console.log statement. That's a function that gets added to the top of the call stack. And the string inside gets printed to the console. I'm cooking jollof rice gets printed to the console. And then the console.log function is done, so it gets removed from the call stack. It gets popped off the call stack. And then the callback function for the set timeout is done as well. That gets popped off as well. Now we're back to the global execution context, right? And there's nothing left to run. Everything is done. So we remove, so the global execution context gets removed from the call stack, and that's the end. Ha! Okay, so this is kind of how the JavaScript engine, with the help of like these web APIs and browser features, executes our asynchronous JavaScript code behind the scenes, right? And that's all for this video. I hope you enjoyed watching it. I hope it was helpful. Thank you so much for watching. If you have any question, please leave them in the comment sections. I will get to them. And please subscribe if you haven't already. I'll see you in the next one. Bye.